Congratulations everyone, we are now done with the DNA viruses. See, that wasn't that bad, but before we move on, let's do some quick review. Do you remember which virus can cause a hemorrhagic cystitis? That would be the adenovirus. Very good. And which virus can cause progressive multifocal leukoencephalopathy? The JC virus. Very good. And why is parvovirus dangerous for sickle cell patients? Because it can infect the red blood cells and cause an aplastic crisis. Very good. So here's a list of all the RNA viruses. Remember, most RNA viruses are single-stranded and are either positive or negative sense. So thinking back to basic virology, do you remember, is it positive or negative sense virus that is more similar to messenger RNA? Remember that the positive sense RNA is essentially an mRNA molecule that is directly translated into the appropriate protein, while the negative sense RNA needs to be converted into positive sense RNA before it is then translated into its protein products. And do you remember what enzyme is responsible for converting the negative sense RNA into the positive sense? That would be the RNA-dependent RNA polymerase. Good, I hope this is sounding familiar. The reovirus is the one double-stranded virus. This virus is not enveloped. It is segmented with 10 to 12 segments of the double-stranded DNA, and it has a double icosahedral capsid. In the family of reoviruses is the cultivirus and the rotavirus. The rotavirus is more high yield for step 1 because it is the number one cause of fatal diarrhea in a pediatric population. Here's the list of the positive sense or positive stranded RNA viruses. The first aid text nicely lists out most of the important information on these viruses. I'm going to avoid regurgitating the table here, and instead I want to focus on the similarities and differences between these viruses. Importantly, all of these viruses are icosahedral in shape, except for the coronavirus, which is helical in shape. The picorna, hepi, and calicivirus are naked, while the flavivirus, togavirus, retrovirus, and coronavirus are enveloped. Remember, along with the reovirus, you can use the mnemonic C, P, R, and hepi to remember the non-enveloped RNA viruses. That would be the calicivirus, the picornavirus, the reovirus, and the hepivirus. Okay? Now, do you remember the 4 non-enveloped DNA viruses? So if we remember correctly, the 4 non-enveloped DNA viruses are the polyomavirus, the adenovirus, the parvovirus, and the papillomavirus. Now we can remember the mnemonic, give pap smears and CPR to naked hippies. Alright, going through each virus family, I want to quickly mention the viruses that are in each of these families. We're going to go over them each individually in more detail as we go through the lectures. The picornavirus family includes the poliovirus, the echovirus, the rhinovirus, the Coxsackie virus, and hepatitis A virus. The hepivirus family includes hepatitis E virus. The most important calicivirus is the norovirus, which is a very common cause of gastroenteritis, which will be characterized by a non-bloody, watery diarrhea that will resolve in a few days. The flavivirus, most importantly, includes hepatitis C virus, as well as the arboviruses, yellow fever, dengue fever, St. Louis encephalitis, and West Nile virus. The toga virus includes, most importantly, the rubella virus, but it also includes the eastern and western equine viruses. The retrovirus family includes 2 important viruses, particularly HIV and HTLV. And the last positive stranded virus family is the coronavirus family, which includes the coronavirus, which is a common cause of the common cold, as well as the virus that causes SARS, or the Severe Acute Respiratory Syndrome, that caused a scare in China in the early 2000s. So now you have all of the important viruses that are present in the families that are positive sense RNA viruses. Now let's talk about the negative-stranded RNA viruses. There are 7 viral families, including the orthomyxo, paramyxo, rhabdo, phyllo, arena, bunya, and delta virus families. To make our lives easy, all of these RNA viruses are helical and have envelopes. Quickly going through each one of these viral families, the orthomyxovirus includes the flu virus, or the influenza virus, while the paramyxovirus includes 4 different viruses: measles, mumps, parainfluenza, and RSV viruses. The Rhabdoviridae family includes the rabies virus. The Filoviridae family includes Ebola and Marburg viruses. The Arenaviridae causes a lymphocytic choriomeningitis and a Lassa fever encephalitis, while the Bunya virus includes the hantavirus, as well as viruses that cause encephalitis or hemorrhagic fever. And then the Delta virus includes hepatitis D virus. Do you remember what virus hepatitis needs to cause disease? Remember, hepatitis D virus requires or needs hepatitis B in order to cause disease. And do you remember what viral genetic mechanism this is known as? It is known as complementation. Very good. The hepatitis B viral protein complements hepatitis D virus and enables it to cause disease. Now that I've thrown a whole bunch of information at you all at once, let's take a moment to digest it all. Here again is the list of the negative-sense, negative-stranded RNA viruses. Now if we rearrange them, we can come up with a great mnemonic to help us remember these viruses. Always bring polymerase or fail replication. This mnemonic not only provides us an acronym that helps us remember the viruses, but it also reminds us about an important concept with negative-stranded RNA viruses. Negative-stranded RNA viruses are complementary to messenger RNA and need an RNA-dependent RNA polymerase to convert them into messenger RNA that'll then be translated into the appropriate protein products. So it is important that all of these viruses must bring with them an RNA-dependent RNA polymerase in order for them to successfully replicate and pass on the progeny to the next generation. So now let's discuss the segmented viruses, and there are 4 of them. So the majority of RNA and DNA viruses are composed of one long linear segment of genetic material. Segmented viruses are unique because they have multiple segments of nucleotide strands composing their genome instead of just one. And the reason this is important is because if we remember back to viral genetics, having segments enables these viruses to undergo a process called reassortment. So if these 2 viruses infect the same cell, the viral segments can mix and combine together, and they can make progeny viruses with unique genetic material or a unique genetic makeup. This process is called reassortment. The 4 segmented viruses can be remembered by the mnemonic BOR, and they include the Bunya virus, orthomyxovirus, arenavirus, and reovirus. Do you remember the important orthomyxovirus? That's the influenza virus. Very good. And now time for a flash quiz. In which RNA viral families do hepatitis A and C belong? Hepatitis A is part of the picornavirus family, while hepatitis C is part of the flavivirus family. It is important to remember which families of RNA viruses the different hepatitis viruses belong to. Hepatitis A, B, and C are the most important ones to remember. A way you might be able to remember this is to remember that acorn for hepatitis A and corn being a part of the picornavirus family, as well as we can see flavor.